Hello, so here's the final video of how to link OpenModelica to Python. So we have already installed on Python, and we're going to see some examples on how to use it. So I'm gonna close this, and first I'm gonna open some files that I already described in previous videos. So I have described this model previously, which was a complex model. And well, doesn't matter detail. But also I explained something about a costume model that I could create, which was a resistance, and this resistance not was not a typical resistance uh, like here, but but was a custom resistance that I created to um, uh, permit to link a txt data boundary conditions file to the model. So you have to see the video. So with that in mind, I'm going to open Python, and I'm going to open Jupyter, which is the file that we're going to work with. So we come here, launch, and I have a test file that maybe I will use. So here again we have this import on Python, help on Python, and it indicates when I launch it that the OMPython file package has been installed correctly. So if you read this uh, guide note, you will have more detail on how to use OpenModelica, the OMPython, and the more practical way is to try to repeat examples. For example, here there is an example of how to use OMPython with OMC session queue. There is an example in the directory. So if you make this, and it's going to call the example file, call it bouncing ball, and it's going to be called loaded by Python, and when it finishes, it means that this mod contains the model bouncing ball. Okay, but for our purposes, we're going to work mainly with the OMC session queue, certainly, but also with the ModBuild model, which is notation that permits to communicate more uh, easily with Python. So there are some configurations, get quantities, that can permit to communicate Python with OpenModelica better. So for example, here I have I'm gonna delete this. Here I have an example of how to use this ModBuild model. So the same OMC session queue, I can Modelica system in this case, which is the yeah. You have to read this so you see that some line codes have to be executed. And here, for example, we define a model path, which is the directory where I have the OpenModelica file. We indicate a name of the file, and we indicate a custom name, which I think it has to be the same as the model. I'm not sure, but it seems it has to be the same. And here when I call mod, I define the model path, the name, the custom name, and here I have to put Modelica as a first, and the second it has to be any other model that is called by the model I want to simulate. So if I want to simulate, in this case, O3B2, and in this O3B2 there is this component, the resistance custom that I created in another model, it's included here. For example, like this. So this is a component that comes from another model. And when I want to use O3B2, I have to specify which other models are going to be needed. And in this case, it's air bar. So, but that's already been done in the original uh, O3B2 model. So there's no need to add another. But when I add another uh, model that is needed, this model has to be copied in this path, OpenModelica Live OM library. Otherwise, it's not going to work. So what I have to do is I have to go to the OMPython model, take this, copy it, and I have to go to the place where I installed OpenModelica, lib, OpenModelica library, and I have to paste it here. I have already done it previously, but I'm going to replace, and that's it. And it has to be here. So once that's done, now we put ModBuild Model, and this can give you the name where the I think the Python files like this are saved by default. So I'm going to make a load this. I'm going to close this also. No, yes. I have nothing open, and I'm going to load this O3B2 file. So as you see, it's charging. All right. So what happened here was so this is what happens. It's saved by default, the error bar. So I'm going to save. So it's done. I'm gonna launch this again. I think it's gonna be a good example. So OpenModelica saves by default from time to time the files. So this is the one I'm going to charge again. It's charging. So there should be a way to avoid to save automatically in OpenModelica, and it's up to you to see on the graphical interface. So here we see it's its charge is loading the OTRB2.model, including the error bar, which is in this directory. And as we see, the process finished, and it has been um, loaded. So now we have in Python this mod variable, which is itself the O3b2 OpenModelica model. So for example, if we want to launch some simulations, here I have the here I have some line codes that are going to help you to link to work better with the model in Python. So for example, here I have the initial time of simulation, which I define 0, the final time of simulations, the step time. I have some parameters names, which are notations used by OpenModelica to describe some components. For example, the resistance, resistance value of the resistance component. We define it like this, and we can assign some values here. And here are some directions for the boundary conditions file, which was the txt, and this is a name for the outlet file. So these are just names, okay? But what is important is here. So for example, I'm going to just if I want to, and remember that I define it as mod, the file loaded. If I want to define the simulation, if I want to define the simulation setup configuration for simulation, I have to define a start time, which I do like this, and here that is 0, stop time is this one, the step size is this, and the tolerance we can put this value, the solver like this, and we have configured the simulation. So if we go here, so step in time. Okay. I have to launch this also. So it has already been charged, and now this, and it's okay. We have already defined. So for example, if I want to obtain these notations, I have to use, I think, this. There is a way to obtain this. I'm not sure which one it was. I think it is get quantities. Yes, it's get quantities. Mod get quantities. We're going to try this, and it's gonna give you all these variables that are in the model. OpenModelica variables, notations that are in the model. So if we come here, so what we have here, yes, we have this C++, T, C, right? So that's that's how I obtain the parameters in the model. And if before the simulation I want to set up some parameters, for example, here I say I want to set up the second element of this vector, which is non-Modelica, which is this element with this value, but I'm obtaining, which is here with this value. I can do it like this. Okay, I can use a loop also to define all the values in the vector like this. And if I define this previously to simulations, so now the value of this resistance, second element, as is defined as this. Even if in the model itself, OpenModelica with the interface graphic is another value. I'm predefining other different values. I can define also the path that I'm going to use for the simulation, where I have the computant table of the txt boundary condition file. So it's going to be in that directory cd, and the directory cd I defined was, as I said, was the place where I have this file saved. So I'm going to say call this in this directory. So what I have to do, this is the file, txt file. I have to copy it. I have to go to the file where I save this Jupyter notebook models. So I have here the, the directory, and I have to paste it here. And I'm going to replace it because there is one. So here it is. So now I say the computant table, you have to call it here, and it's defined. I don't think I have to call it, but if I launch the simulation, the file has to be in this directory where I placed it just now. And now I'm going to simulate this model with ModSimulate, and I'm going to call this like this. So I'm just going to simulate. Okay, here close. I'm going to do it again. So it's finished, and the file that has been created containing all the results of simulation, I call it like this. But the file created is going to be like this. So I load in this virtual space the results here, but what was saved in the disk is this, and this is called I think I define it Fisher as Modelica mat. Yes, it adheres. The material is 0310 mat. That's Fisher. So if we come here, we shall find this file here. So created and here it is. Novatec is 03bit temp, and this is the mat file that has been created just now. Right. Which is 750, 748. Finally, if I want to get the results, I can use this mod get solutions, and I going to I can get solutions like this. where this is the file that I loaded here, and this is another this is a custom name. um, what, it doesn't matter. So for example, if we come here and we obtain get solutions just like this, yeah, here I can precise which outlet I want actually. So that's what it was. This here I was indicating which outlet I want from this file. For example, I can put a time, height, or a specific temperature. For example, I can put oh no, I think I can put this. Oh no, I can put an element. For example, I'm just gonna create something like this. You have to verify it. You can put something like this. I don't know. How is this? Alright. Something like this, for example. Let's see, it's gonna work. So if we put this, so from all the results, uh, let's see what it has this. So it has, of course. So here I said, well, all the results of this simulation are in this virtual variable. But from all the results, I just want the temperature in this capacity. So I define which one I want, like this, and I said I want this from this file that is here. Get solutions, it is here, and after I call, and I see that I have an array with all temperatures obtained in your simulation. You can put this is a vector, so if you put something like this, for example, so you obtain everything. And you're going to obtain all the all the solutions, but you don't have the detail, right? So that's it. For further detail, you have to use this, and you have to play with the code, with the package. But it's possible to now simulate OpenModelica with Python. I gave you already all the tools to let you do it. So thanks for watching. I hope it helps to develop more knowledge in the scientific context. Thank you and have a nice day. Bye.